All right. Hello, everyone. Welcome to our 14th user group meeting. Today, we will be covering a number of topics. By the way, here are here's the content for our previous 13 meetings. You can always find it on our YouTube channel. So if you miss anything, don't worry. It's all recorded. Today, we will be discussing a few topics. First, we will introduce a new long-awaited feature. It's frozen rows and columns in the spreadsheet. Then we will go through some visualization improvements, because we always keep improving that part. Then Leonid will go through Cheminformatics Improvements. And then finally, Alexandra will tell us about the new functionality she's built for elemental analysis of chemical structures and some additional visualizations. And then I think the last 30 minutes or so, we can have question and answers sessions. Then we also might discuss our topics for the next meetings, so we can also do it during our Q&A. And of course, at any point of time, you know where to find our help. Well, just go to our website, DataGrok.ai, and right from there, you'll see all of these links, all these interactive videos, documentations, tutorials, and everything. All right, let's get started then. I will go through the first section, and please interrupt me at any point of time, ask questions. Yeah, that's meant as a session for you, so don't hesitate, please. Okay, our first feature that we are going to cover today is frozen rows and columns. As you might have seen already, our spreadsheet is a pretty powerful and high performance and flexible one. And today we are introducing a couple of new features. So usual pain point for users is that quite often tables are very wide, and as you scroll to the right, you lose the most important columns, which are often, for instance, molecular structures. Now you can pin it or freeze by right-clicking on a header and selecting pin columns. That's everything that should be done. After that, the scrolling is seamless. Everything is still synchronized. At any point of time, you can unpin it. Also, it's possible to pin more than one. I'll just select them, choose pin. It works like that. And then you can unpin either individual ones or all of them. This information will get saved in a layout. So if you save it as a project or a cell layout, it will get reapplied. Any questions before I proceed further? All right.
What was that? I'm wondering, first of all, whether my microphone is working, because I'm wearing a new headset.
It's working.
Yeah. Excellent. What was that menu to script underneath? Is it related to freezing columns or what?
No, it's not. I'll send you a link later, Dima. In short, it's for converting a viewer to either a Python script or a JavaScript to reproduce it. So not exactly relevant in this context, but you find some use for it. So I'll write to you later.
Excuse me, I have a question. How can we create a project from the beginning so we store all the relevant files in a single place?
So typically, you simply import your tables like I did. I already have a number open. Then you go to the projects tab. Then you do upload. This will create a new project that you can name. You can also specify the exact content you want to share. It could include objects other than tables and views such as connections and functions, and some of the data sources could be dynamic as well. After you are done with that, you click OK. At this point, it's uploaded, and at the same time, you can share it with someone. So yeah, in a nutshell, that's how to do it. If you also have questions that would be more specific, you can always ask also in the community. We can help you here. We can also discuss it in a little bit more details in our Q&A session slightly later. Okay, I'm moving on meanwhile to the next feature that we are demoing today. It's somewhat similar to the frozen columns, but you probably guessed it, it's frozen rows. So in the very same manner as we can freeze rows, we can select our objects or molecules of interest. For instance, I want to compare everything to this molecule, and I want to always have it in my view. Right click and choose pin row, and it gets pinned. Now, no matter where you scroll it, the pinned one will always be on top. In a similar manner to the frozen columns, you can also pin additional rows. And you can unpin them, of course, just right-clicking on them. You can unpin either all or some. Let's unpin everything for the moment. And we are back to how we started.
It's a little bit misleading, though, that the row index does not stay. If you look at it, you know, if you pin a row and scroll them, this particular row does not retain its index, I think.
No, it's index 4. It's up here.
It's just not shown, right?
Yes, yeah. Because yeah, the index has very little meaning, right? It's just the index of how you do it. So we do not show it. Yeah, what's cool is that you can sort, and of course it will stay on top no matter how it's sorted. It's pretty convenient when you work with collections where you have some reference compounds or reference anything.
Frankly, I would still prefer the index to be shown so that you know which row is actually pinned.
Could be, yeah. We might do it, Dima. Thanks. Right. Any questions regarding the frozen rows and columns? Okay. Moving on. Now I will give an update on some of our visualization capabilities, and we've made good progress on visualizing hierarchical and linked data. And later on, we will show even more interesting functionality. But at the moment, let's see how we can visualize linked data.
By who owns it to build it.
Sorry, Walter, I have muted you. There was sound coming from your mic. I'll unmute you later. So now to linked data, hierarchical data, and essentially data that has relations. We have a number of different visualizations to deal with it. So one of them is the network diagram. In this data set, we have a collection of edges. It's actually the description of Game of Thrones, I think, first season, where we have heroes in 2 columns, source and target, and their type of relationship. So that's the way you typically, one of the ways you typically store relational information in a database. And now, and that's a pretty old feature, this particular one, we can visualize it in form of a graph, where we would specify the source, the target, essentially 2 columns that represent the relationship. And we see the whole network of our nodes and edges. As you can see, the layout is dynamic. So we immediately found out a couple of patterns. For those who watched Game of Thrones, so these are 2 different continents. I forgot the name of it, but if you follow the movie, you should remember the names. So it's a nice way to understand the nature of your data.
By the way, I just started watching season 1, so where can I find this data set?
I'll send it to you. It's on our public website.
It'll be really cool to actually add the pictures also.
Thank you, Dima, for a good question. We actually had that idea too. Great minds think alike. So if you, so there are plenty of options here. We can size code pretty much anything by node, by edge. I'm not going to show all of that because we will run out of time if I do that. But one of the settings that actually Dima has asked is, just a second, had something with Google, yes. It's called to use Google image. When it's on, what Datagrok is doing is issuing a call to a Google image search, and it returns the first occurrence. So actually, Dima, you can now explore your data set just like that.
Yeah, that was pretty cool, but I noticed that one of the things that you hit showed something IKEA.
Yeah, I mean, the name is not descriptive for us, right? We only have 5 columns, and there is no magic, of course.
Yeah.
Yeah. So that's how, in a nutshell, this network diagram works. It's also interactive. You can drive other visualizations with it. You can see the selection is synchronized, good for exploring relations.
I assume you would be able to show chemical structures inside those circles, right? If you're dealing with chemical compounds that have certain relations to each other.
Exactly. Actually, let me.
This is quite common.
Right. Yep. Let me open some data set, and let's see. Okay, we got some R groups and cores. Dima, you are asking really good questions. Let's try to see relationship between R1 and R2. Oh, so many different ones, too many. That might not be the best example. Oh, since there are thousands of R's. Well, we still see the structure, which is pretty cool, and it will stabilize and we'll see the patterns. Now it's performing the dynamic layout. but it will be too cluttered to see the molecules. We also support a way where we can do, for instance, on the fly, the R group analysis. Oh, that's my local drive. Okay, I will not be showing it at the moment, but yes, the molecules will appear inside the nodes. All right, so moving on from this network diagram, we actually had this visualization for a while, but I just wanted to provide a refresher. The new visualization that we have here is a tree viewer. So now we are looking at my favorite demographics dataset that has subjects of the clinical trials in rows and attributes in columns. And by the way, this is how the network diagram would look like when we would explore the relationships between disease and race. So and color coded by some attributes, average, height. It's already usable to find out where the majority of the subjects are and what are their characteristics and what are the characteristics of their relationships. And you can explore it interactively, easily. But I will close this visualization at the moment, and I will focus on another way to look at this data. As you can see, it defines no explicit relations, but certain categories are, certain columns are categorical. So in a way, they define implicit hierarchy. And one way to look at it is using a tree. To start it, I would go to add the viewer, and I would add a tree viewer. Now what's happening is that the visualization, it automatically chose some categories that that define the hierarchy. So the first level, as you can see, is sex, then race, then control. So this means
how does it choose the levels, by frequency or by the order of the columns?
By the number of unique values in it.
Yeah. Mm-hmm.
Yeah. So we only had 2 sexes, and then 2 controls, true or false for each one, and then the next one would be, I think, race. But this is just the default way of visualizing it. If we want to, we can change it on the fly, and let's introduce the DCs. So yeah, now we actually see all information, all categorical information, including the DCs. And it's different from the network diagram, but it's useful when there is some sort of hierarchy, or if you want to group rows and explore them. Of course, it's interactive. It follows the same controls as the rest of the platform. So you can select categories by pressing Control-click and so on. And all the viewers are also synchronized. And since I have a scatter plot open, I want to demo another feature that we've recently implemented. Of course, on molecules, we have our data set open already. Now let's add a scatter plot. As you know, also, it's easy to customize the scatter plot. Right on its surface, there are controls that let you choose x-axis, y, color, size, and so on. There are also a couple of hidden axes that we do not show by default, and one of them is labels. By default, it's turned off, but I might want to choose something like LCMS, pass or fail. So now we see additional information which might be useful to us. What's more is we can also render molecules right here. Let me zoom in to have slightly less data. And let's say I want to visualize molecules, and this is it. So now we are looking at the actual renderings of the molecule in the space that we have selected, which is pretty convenient. Well, depending on how dense it is, it might or might not be useful, but there are many cases when it's pretty useful. This feature is used in conjunction with another one. We can select which labels should be shown, because indeed sometimes it gets too cluttered and it's impossible to figure out what's going on here. In this combo box, show labels for, we can select the type of rows that should be visualized as labels. For instance, if we say we only want to show selected ones, then see, as I'm selecting rows in a spreadsheet, they appear here. Or I might want to select them right on a scatter plot, like that or like that. So pretty convenient when you are interested in a couple of molecules and you want to always have them visible and not lose their position on a scatter plot. Another interesting way to represent it is to use, well, first of all, we can do, for instance, current row. So now it shows one current object, or mouse over rows. In this case, a subset of molecules that fall under the mouse will be shown. So in this case, what I'm doing right now, I'm opened a histogram. So let's visualize something useful, such as in vivo activity. And now notice, as I would move my mouse over the bins, these points, they get highlighted in the scatter plot, but also the labels for them are selected. And this is a pretty easy and interactive way to explore collections of anything, in particular chemical structures. Okay, any questions regarding the scatter plot visualizations or what we've demoed previously?
Yeah, it looks pretty cool. The only thing is that sometimes it's kind of hard to figure out to which marker, which molecule corresponds, because they're shown at a certain distance and you can't really tell easily which one is which. But I do not know what can be done about it, frankly.
Yeah, they use the same shift. So once you figure out how they are shown, it's not that hard to distinguish. but indeed, it's not ideal because it can get cluttered. So it's just one tool in a toolbox. All right, if there are no more questions for visualizations, Leonid, please take the stage. I will make you a presenter.
Yeah, thank you, Andrew.
Yep, you are a presenter now.
Can you see my screen?
Yes.
All right, so we are now focused on chemical structures, notation consistency, and covering new chemical file formats. And to demonstrate it, let's see the data set containing mol v3000 file notations. So for the end user sees the structures, but for each structure corresponds to each file. And we will now see that this one is represented by mol v3000. Under consistency, I mean that if we use any data grok feature related to chemistry, it will return the structures again in that notation, in that original notation. So for sketching, we can modify the molecule, and it will return from Sketcher to this cell as mol v3000. And we can return its rendering as molecular graph. The same thing will work with mol v2000 and smiles, and you actually won't see that if you wouldn't like to. But this will save all your data in that notation that you're using. The other thing is covering new file formats. The platform originally handles mol files and smiles, but one can use any different types. For example, we now support SMI format in its both forms. Simple smiles, when only smile strings are written to the file, and complex smiles, which is formed like tab separated file. The same thing will work with mol2 and some other files in the nearest plans. Not only small molecules, but also the macromolecules are now supported. And we can show and observe the files containing PDBs in CSV tables or not. All the three-dimensional structures will be rendered in your table. And you can see these files, these structures as they are originally presented for PDB views. To precisely examine the structure, you can just click on that. And in the separate window, you will see the viewer with this molecule and maybe with inhibitor, like in this case, that are contained in this file. We will continue to cover more different notations. And now I would like to show you one of our new features.
Leonid, I have a question. So, so you've shown the PDBs in this spreadsheet. How how would I do it? Should they be embedded in a cell, or can I introduce some sort of hyperlink?
You can just drag and drop the file like I did, or in this file you can contain the whole PDB or the hyperlink, right?
Oh, okay. And how it will figure out that it's a link to a PDB file by just the extension of a hyperlink, or?
Oh, it should contain the data that is related to PDBs.
Okay.
I wonder if you can just show that file in the text editor. What does it have in it inside?
For this
Yeah.
certain case, well, I don't think that for this certain case, the whole PDBs are stored. So
Oh, I see.
Okay.
it contains the whole structure. Though, as Andrew mentioned, you can contain hyperlinks if this file is stored.
Mm-hmm. All right. Okay. So depending on your use case, you might prefer one or the other. They can be huge, of course. Okay.
These certain ones are huge, right? Though in PDB you can store smaller or even bigger structures either.
Mm-hmm.
Maybe before we proceed, maybe any other questions on file notations or file formats that are gladly to be supported.
So when you import an SD file, which contains multiple chemical structures, how do you deal with the tags? Because each molecule can have a set of tags in the record, do you show the union of all tags, or you take a sample of like first few molecules and then create columns?
That's a very important question. Just for now, it is checked if all the tags, but by tags you mean properties in SDF file, right?
Yeah. Sometimes they call them tags, sometimes they call them properties. You know, it's basically the things that start with that greater than sign, and then the name, and then the value underneath.
Just for now, it is checked that all the structures contain equal fields, but we're going to enhance it to analyze if there are spaces, or if some of the entries do not contain specific field.
So what will happen if you have a mixture of molecules from different sources and they have different fields? I mean, not all of them have the same fields. Is it gonna like create columns which are the superset of all fields, or discard some of the fields?
I think we can try to eliminate one of the fields for the cement file for now. And it was okay, but it removed the field that was not present for the first entry.
Mm-hmm.
I vote for keeping all the fields.
Mm-hmm.
Yeah, on the other hand, of course, you will have to parse the entire file before you can create columns, because you can never be sure. You know, it may be a huge file, and only maybe the last molecule, and like out of like 5
yes,
million molecules,
case,
and then the last one has different fields. So you'll have to read the whole damn thing before you can actually even create columns.
in this case, we have to read and parse the whole file, right? But I think that we will handle this and propose 2 different ways of opening it with no bothering of user, of course. Mhm. So, and one small new feature, and it will now work with all notations, even if the set contains a mixture of different notations like smiles, moles, or mol v3000. It is related to finding the structural alerts that could somehow interfere with your project. For example, very popular paints for drug development to detect the structures that have fragments that could apprise the toxicity of the whole structure. And using it, you will get the classification column with paints. If the molecule does not satisfy these rules or contain the fragment, one of paint's fragments, is just the classification, and you can then use it as filter. So you can just remove all the structures that have it. But if you're going to examine what actual paints is presented there, you just you can examine it just right in the panel and see what paints fragment was detected. So I think that's all. Any questions?
Well, looks pretty cool. Just one question. So when you import a file into a table, does it actually keep the original chemical structure representation, or does it do any conversion internally? And so does it always store molecules in the original format or not?
That depends. If you're using mol v3000, mol v2000, or smiles, they are stored in smiles, mol v2000, and mol v3000. If you're going to use mol2 file format, it will be converted to one of these.
Mm-hmm.
That is required for calculations as internal RDKit cartridge works with smiles, mol v2000, mol v3000 to make calculations.
So these two formats we always support natively. So no matter which format the molecule is defined in, the rest of the functionality will work. And yeah, others are converted on the fly to one of two.
Mm-hmm. Yeah, that looks pretty good.
So again, just to briefly repeat, if you detect paints, you can click on each of the molecule and inspect what specific fragment was detected to show you this alert. So I think that I can stop the presentation.
Yeah, thanks, Leonid. I think you are now the host. Can you please pass the stage to Alexandra?
I will try.
Okay, actually, I reclaimed host, sorry. And yeah, Alexandra, you are now the presenter.
Okay, thank you. Right now I'm going to share. Can you see my screen? Everything's all right?
Yes.
Oh, that's great. I'll do like that maybe. Okay, today I'd like to show you elemental analysis. It is a tool that lets you extract, visualize, and compare atom counts for the molecules in your dataset. So what can you do with this tool? With this tool, you can get columns with atom counts and get a radar chart for every single molecule. What should we do to run elemental analysis? We need to click Chem elemental analysis in the top menu like that. So here is our dialog. There is a table, so our data set on which we want to perform the elemental analysis, also the column with our molecules. And here you can see there are two options for our radar chart. So radar chart can be visualized in two ways. The first one is in the view, and the second one, the column is going to be added with radar charts. I'm going to perform both ways for you just to show how it looks like. Let's do like that and click on the OK button. So as you can see, right now we have our columns with atom counts. The atoms here are in the same order as in the periodic table. So, and when I'm showing you a radar chart in the last column, it was added. And also we have a radar chart in this view. Right now, I want to tell you more about our radar chart options and what can we do with it. So on Radar Viewer, you can compare the numerical values of different columns within a row and gross values within a data set. So Radar Viewer is commonly used in the comparison, decision-making, and analysis. So as you can see in elemental analysis too. To configure a radar viewer, you need to click on the gear icon here and use the MISC, colors, and data info panels on the context pane. So, for example, you can set the mean and max percentiles here. So there are options for mean and max percentiles. Even a description is provided for those who have this for the first time. So the minimal value here is rather small. That's why it is near 0. I will propose you to swap to 25. So, and to play with colors in order to see this minimal value better. For instance, let's do like that. Right now you can see the area for the minimum percentile. Also, you can play with max percentile and switch like that. There is no problem. You can just show the current row like that, or return to the first representation with minimum, maximum percentiles. There is also a tooltip here in order to show you the atom counts. You can show minimum percentile or not. It is your choice. The same is with max. You can show values or not. Also, right now you can choose the data you want to see on the radar viewer. For instance, for the elemental analysis, I don't think that it's really important, but for other data where you have more than 20 columns, you can just choose which columns you want to show here and click on the OK. So I believe that is all I can tell you about elemental analysis and opportunities of our radar viewer.
I'm wondering if you can simply create a column that contains an elemental formula like CM, et cetera, instead of creating all those columns with the elements and the counts, and just like do the regular chemistry representation.
In order to run elemental analysis?
Yeah, I mean, if instead of creating all those columns with atom counts, you just create the formula, you know,
okay,
in one column.
I guess we can. You think that it's not really great to add really such a big amount of columns with atoms, and it's better just to show the one?
Yeah, they're just the regular chemistry presentation, like
I think we can give a user a chance.
Like C6, H22, 011, something like this.
Yeah, I guess your
I
point.
agree.
Yeah,
I think we
because
can.
I've never seen any chemist trying to like to create a representation like this actually, because it's not super useful.
Okay.
Unless you're very interested in some specific atoms, like for instance, a number of carbon atoms, you can sort of sort
I
by
guess.
them, or
I guess.
number of heavy atoms, which is a useful feature. But showing all elements, like this, is not super useful.
Okay, we can do this, of course, and then give a user a chance just to choose what he wants. Maybe someone will want to play with all these columns, and for other people, it's better to do as you've said.
I'm a chemist, so I've never seen anyone doing this. Like wanting to show all the element counts and separate columns, with some exceptions. Like for instance, people are quite often interested in some specific atom counts, like number of nitrogens, number of oxygens, but they're usually a few select atoms that they're interested in, but not the entire elemental kind of composition. And the elemental composition is usually presented as just a regular formula, like, as I said, like C6, H22, 011, something like this.
Yeah, actually, Dima, we have that already. Alexandra, can you please scroll to the left to show the structure? To the left.
Yes, right.
Yeah, now click on the structure. One below to. No, just click on an element to change it in the property panel. Click on the molecule in the second row, please. Okay, yeah, now open properties. Nope, not the mol file, properties.
I'm doing.
Yeah, so here you see the formula. Yeah, we can.
Yeah, that's what would be nice to be able to like create a column with.
The column with all those formulas. Yeah, I get your point.
Yeah, I'm pretty sure we have a way to do it in the UI already too, but let's not try to find it.
Just not to click on every row and to get this formula, just to have it in one column and to scroll.
Yeah, and maybe even all other properties that you have over here, like molecular weight, number of hydrogen bond acceptors, donors, etc., sort of shown as columns quickly to add columns containing this information, because this is actually useful information.
Actually, that's a good idea. I like that UX, Dima. Just a link right next to the property of a particular. Yep, we will do that. Thanks.
Yeah, so for make a column out of this thing, like.
Yep.
Yeah.
We'll do that. Thanks. And by the way, people use it. That was actually a request from one of our clients to introduce the elemental analysis. Maybe Leonid, do you want to?
Yeah, you can use it for data-driven purposes, like for this data set. You can see that there is a selenium in it, and these are the inhibitors of HIV, and you can just remove all ones that contain the atoms that you don't want to see in your data set. As you know, they will be the highly active inhibitors, but you will not push them to in vivo studies, for example.
Yeah, maybe there are some rare cases where it can be useful, but I mean, usually people search for undesirable groups, which can include certain types of atoms. You just do a simple smart pattern search, and you're done. You can search for like certain elements as well.
Yeah, sure.
Yeah,
of course,
but
if you curate your data yourself, it's the one case. But if you just download the data from the external sources, you cannot be sure of their composition and their peculiarities.
yeah, of course, one of the most useful representations that it's really hard to implement would be to show like simulated NMR, for instance, for each molecule. That's what organic chemists would love.
Oh, you think so? Oh, I saw that feature in, for example, ChemOffice.
Yeah. I mean, that's like bread and butter. I mean, show like a H1 or F13 NMR simulated, but it's really difficult to implement unless you kind of have a toolkit to do that. It's not something that you can simply program in 5 minutes. And mass specs are also quite useful. So, but those are highly specialized viewers, but it'll be they are kind of highly demanded. So simulated NMR, simulated mass spec.
We should consider that then.
But you will have to rely on third-party tools to do that, I think, because that's like you're not going to be re-implementing this.
Yeah, for sure.
Okay, thank you, Leonid. Yeah, thanks, Dima. Let's also spend maybe a couple of minutes discussing our topics for the next meeting that will happen in about 3 months. So that's what we have on the plate at the moment, but we are open to any ideas and suggestions, so this can change. What we are planning to discuss next time is first, we will have our implementation of the ADMET calculators. So you'll be able to compute many dozens of different ADMET properties for your local data sets. Then we are planning to discuss the implementation of the scaffold tree. And for those who do not know what a scaffold tree is, essentially this is a way to navigate and categorize your data set of molecules. In such a way, it's a hierarchical structure where in the root, for instance, you have the most common substructure, and then each node is a super molecule of a previous one. So this way you can conveniently navigate your data set. And there are different ways to both automatically generate this classification and also interactively navigate. We've almost completed the implementation at the moment. In fact, we were planning to demo it today, but I decided to postpone it. And next time it will definitely be ready. So this is what's coming. Also, what we are planning to discuss is we have the ability to cluster the data using hierarchical clustering and visualize it in a dendrogram connected to a spreadsheet. So that's also a very convenient way to analyze your data. And another big topic is our modeling environment that we've built that is currently used by one of our biggest clients. It's a way to productionalize calculations implemented in any language. So it's pretty interesting. Any thoughts, ideas, requests?
Well, the usual one, fix the merge tables.
Noted. Yeah, should be done. All right, if there are no questions, ideas regarding the next meeting, yeah, I'm opening it to any questions that you might have regarding the platform or suggestions. So absolutely, any questions how to save layouts, projects, files? We can do a demo. It's your time.
So when you're actually looking at the table or any kind of data inside Datagrok, is there a clear indication as to whether this is local or persisted in the project?
Yes. So you have to open the projects tab, and actually, remember in the beginning of the demo, I uploaded a project and shared it with someone.
Mm-hmm.
This is the project. I didn't give it a new name, so it has the silly new project name, but it's a separate project that is uploaded. Also, I've opened some local file, which now resides in what we call a scratchpad. So this is your local files not connected to anything. So if I were to just go and open some more data, boom, see, it will appear in the scratchpad. Now, if I go ahead and let's give it a meaningful AAA name.
Can you actually add it to the existing project?
Good question. Alexander, can I?
Because it's quite a common scenario. You sort of work on the project and then incrementally add stuff.
So can we, if I understood correctly, the question is whether we can merge two projects together or move
or add data from Scratchpad to an existing project.
Let's try that. I have a feeling it should be doable by simply drag and dropping. And let's see if it works. Ooh. Yep. And that's how you do it.
So you basically just drag and drop from Scratchpad onto one of the projects, right?
Yes, exactly. So let's do it again with a different file. So I'm opening the Gapminder file, adding it. It opened. Now I go to projects. We see two projects created previously, and I can just drag Gapminder to the AIA project. And now it's part of it. So it's part of the project, but it has changes in it. That's why the upload button is active. So once I upload it, it grayed out, meaning it's on a server and you made no changes. Everything is good.
Mm-hmm. But now we have sort of two instances of that Gapminder, one on Scratchpad and the other one in the project. How are they related to each other, or they're two different entities altogether right now?
An entity can reside in multiple projects, so it's okay if table added to two projects or more. It's okay. So any entity actually has to be in, I don't know, to be in at least one project, in your user project or in the project with name like AAA, AAA right now. But other projects can contain a link to entity. So it's okay for a table to be in two projects simultaneously.
Mm-hmm. But once you upload, then they become unrelated. So if you, for instance, if you have created the structure and then you have, for example, if you add the Gapminder to new project, right? So you'll have Gapminder in new project and AAA, right? They become totally independent of each other, right? So if you, for instance, edit data in the AAA project, it has no effect on that same table in some other
No,
project.
it's not true. If you upload the table as a part of the project, and then if you add this table, or basically not just a table or any entity to another project, you add it as a link. So it's the same entity, it's the same table, same data. So
That's how it works.
yeah, if you change data in the table and upload it, when you open another project that table belongs to, you will get new data.
Mm-hmm. So essentially, each table is a unit, and then a project only contains a link to it, right?
Yeah, it's not quite true too, but yeah, you can think of it like that, because if you upload table first time, table is added to a project because each entity must reside in the project. But when you add a table in more and more projects, you add it as a link by default. So each time you add an entity to a project, you add a link. Because you must explicitly clone entity to add a copy.
Okay. Can you have two tables with identical names on the project?
Two tables with identical friendly names can be added to a project, but down below, under the hood, Dendrogram has special command names, and tables will be renamed. So Dendrogram adds number after similar names. So even if you add two tables with the same name, somehow it would be a friendly name of a table. So the name that actually doesn't reflect anything is just a friendly name. But the name of the tables would be different.
Also, suppose you have a table shared between two projects, right? And then you make changes. You open one project, you may or may not even open some other project that has a table that may be not even opened in your environment at this point, right? So you make some changes. For instance, you remove certain rows or add columns or compute something that adds columns, right? At which point are the changes saved? Do you have to explicitly click on upload every time, or does it do it?
You have to explicitly upload the project.
So when you upload the project, that means that it actually saves all the changes to each of the.
Basically, when you upload the table, but uploading the project uploads all the tables in the project automatically.
Because I do not use Dendrogram that often, maybe I'm just not used to this. I feel a little bit uncomfortable all the time because I can never be sure that I've saved all my changes, and what exactly gets saved.
There is definitely a room for improvements, and we have a lot of thoughts on that, and we actually have a project our internal project to improve all of these processes.
Because I'm used to, like, say you open Google Docs or Google Spreadsheet, for instance, right? So the changes are saved as you make them. Essentially, you don't have to worry on clicking or anything.
Yeah, I completely understand. I think we need a better indication for unsafe changes. So it's now this upload button. But anyway, we need a better way. I completely agree. And we.
Yeah, because you actually have to explicitly click on that project button on the left to open this thing to show the upload buttons. Otherwise, you can just simply forget and quit, and then you say, "Oh man, I did all that work and I forgot to save
I
it."
think we need an indication for that, and we'll do that.
Yeah, that's one thing that sort of comes to my mind. All right, that's all for me.
Okay, thanks, Dima. Anyone else? Any questions? Requests? All right then. Thanks, everyone. I think we can now close the meeting. And thanks to all presenters too, and to all guests. And hope to see you again in 12 weeks.
Thank you for attending, and bye.
Thanks. Bye.